High school mathematics success depends on the ability to answer maths problems correctly. There's a good rule of thumb to answer all of them correctly. I like to think that there are two types of maths problems, explicit and implicit. Depending on the problem is how it should be approached. An explicit problem is easy. Explicit said what you want me to do. Like 9 times 6, that's 54, and you have given me an equation. I can simply compute this. A calculator could solve this equation, given I put the inputs in. Easy peasy. An implicit problem is hard. Implicit because the information and what you want to find is implied in the words. It's given, but is not written mathematically. These are worded problems, diagrams, anything that's not a literal equation that I could just put into a calculator and solve. Calculators are dumb, and to the calculator, an explicit problem is in its language, but words, images, anything else is like a foreign language. So as a human with intuition, I need to essentially translate this implicit problem, be the interpreter for the calculator, and turn this abstract concept on paper into an equation or an explicit problem to be more specific for the calculator to solve. So there are two types of maths problem, explicit and implicit. Explicit problems are like an equation. I can solve it then and there, using only mathematical working out. Implicit problems require reading a text, looking at a diagram, or reading data points, and somehow turning it into an explicit problem. So how do we do that? Explicit problems are easy to solve. Just put them in the calculator, and you're doing great. Implicit problems should be approached in whatever way you find the most intuitive, but here's my strategy. Step 1. Write out all you know, and all you want to know in a nice variable format. Write a key, or a table, for the scenario, and what we're given, and what we want to find. Let's use an example to supplement this. Tenzin is buying 3 pencils and 2 pens from a stationery store for the school year ahead. His total bill is $22. Some expensive pens and pencils. And a pen costs $3.50. How much does a pencil cost? So we can obviously identify that this is an algebra problem. Lovely. This means that we will be able to write out our information as an equation rather than just a bunch of words, as I've got here. So we can definitely turn this into an explicit problem with some X for the pencils that I could put into a calculator. So let's write out what we know. We know that the number of pens is 2, the number of pencils is 3, the total price is 22, the price of 1 pen is $3.50. We want to find the price of 1 pencil. So step 2 is to identify the equation. Sometimes this point is to identify which known equation, like some trigonometry law or Pythagoras or some formula that we already know is true, and which of these to use. It'll always be an equation that has many unknowns, but we can replace all but one of them to solve for that last one. So if there's a predetermined equation, we can input our known values that we wrote up in step 1 to try and solve for some unknown that we want to find, or some unknown that's an unknown in that formula. Keep in mind, if you have multiple unknowns left over in your formula, it's impossible to solve. So I could say that the price of pens times the number of pens plus the price of pencils times the number of pencils would be my total bill. Do you agree? So let's write out this equation as step 2. Step 3 is to substitute the variables into the equation with the numbers. So now I have the equation 3.5 times 2 plus p times 3. Rearranging this to solve for p, I now know that p is equal to 5. What did this correspond to on our table of variables? The price of the pencil. What did I want to find? The price of the pencil. All of a sudden, it's solved. Hooray! Naturally, that was a very simple example, and this can get a lot more complex. A calculus problem in the form of a race car going down a track. Maybe a matrix shopping problem with sharpeners, rubbers and rulers as well. A geometry puzzle in an image form instead. But ultimately, these are all just implicit problems. You simply write out in a neat table all you know and all you want to know, assign variables to them, and then use formulas or logical equations to essentially fill in the gaps of the table, so you know everything about the problem. Once you're done, you usually already have answered the question it is asking, because the problem usually asks for the value of one of the unknown values, not given to you immediately. I'll make a video with some more worked examples at a later date if you want, but I have a feeling you've got it all under control.